So today we can do the fourth example from electrostatic charges and fields. In the question you can see that a charged metallic sphere A is suspended by a nylon thread. Another charged metallic sphere is there. It is held by an insulating handle such that the distance between their centers, it is marked in the question as the distance between their centers is 10 centimeter. The resulting repulsion is noted. For example, these are having the same charges, right? Both are positive charges, so there will be a repulsion between them. You know that like charges repel and unlike charges attract each other. So since both are positively charged spheres, there will be a repulsion between them. So that repulsion is noted. Then in the next step, sphere A and B are touched by uncharged spheres C and D respectively. So you can see in the next step, a sphere C and sphere D. These two are initially uncharged. So this uncharged sphere is made to come in contact with A, and another uncharged sphere D is made in contact with B. C and D are then removed and B is brought close to A. Okay. After that, the C and D removed and the A and B are again brought closer to each other. Now the distance between them is halved. Earlier it was 10 centimeter. Now they made it as 5 centimeter. And the question is, what is the expected repulsion of A on the basis of Coulomb's law? And also they are given that spheres A and C and B and D, they all are of identical sizes. Ignore the size of A and B in comparison to the separation between their centers. Okay, these all things are given in the question. Okay, so what we have to find out is we have to find out the force of repulsion in this case. Okay, so we can consider the initial charge in A. We don't know what is the charge actually, so we are considering the initial at the beginning. In this stage, the charge in A as Q and charge in B as Q dash. Okay, and the distance between their centers, even though it is given as 10 centimeter, we are representing that 10 centimeter with letter R. Okay, and what is the equation for finding the electrostatic force between two charges? F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. This is our formula. So just substitute the value here. So you will get the electrostatic force in this case as F is equal to what? F is equal to 1 by 4 pi epsilon 0. Our charges are Q and Q dash by R square. Okay, this is up to the first case. After that, what they are telling, they are taking C and D closer to A and B, getting it in touch between them. So what happens when these charged spheres come in contact with each other? Redistribution of charge happens. Charges will flow from one to another until the charges in them will become equal. Okay, so we already told that the charge in the first sphere is Q. So when it comes in touch with the another sphere C, what happens? Charge redistribution happens. That means the charge on A will become Q by 2 and charge in C will also become Q by 2 because the overall charge is Q. C is uncharged at the beginning. So when they touches together, charge in A get divided and given to C. So each of them will get what? Q by 2. And also when D is, we took D as the charge in B as Q dash. So when D touches it, the same thing happens. Charge in B become Q dash by 2 and charge in D also become Q dash by 2. So the new charge in A will be Q by 2 and new charge in B will be Q dash by 2. And in the end of the question, they are also telling that the distance is halved. So our previous distance is R. Now our distance is what? R by 2. And again, we can find out the new force. That is what they are asking in the question. So the new force F dash is equal to 1 by 4 pi epsilon 0. The new charges are Q by 2 and Q dash by 2 divided by the square of the distance. Now the distance is R by 2 square. So 1 by 4 pi epsilon 0 Q dash by 2 times 2 4 divided by R by 2 square is R square by 4. This 4 and this 4 can be cancelled. So we will get the answer as 1 by 4 pi epsilon 0 Q dash by R square, which is same as our initial force. Which means that after doing all these things itself, also the force is remaining same. There is no change in force. And that's the answer for this question. Hope you all understood it. Thank you. We will do the next question in the next video.